Hi, and welcome to part two of the lecture on soil. If in the last lecture we talked about what layers soil has and where soil comes from, now we're going to be talking about what soil is made of and what it's like, what its characteristics are. So let's start out with what it's made of, soil components. There are four main types of things, and you're going to see some of the same types of materials that soil is made out of here that you also saw when we were describing the different layers of soil, which kind of makes sense. Sometimes the things soil is made out of just form particular layers. So starting with the part of soil that takes up the most volume, you've got inorganic materials, things that were never alive, that are basically what you think of when you think of rocks. These mineral particles, they come from weathered parent material, so old bedrock that has somehow been broken down into smaller pieces. And of that, you basically have three different kinds of inorganic materials. You've got sand, which are the big pieces, silt, which are slightly smaller, and clay, which are very, very small particles. Organic matter, the second main component of soils. This doesn't take up a lot of the space in soil. It's only about 5% in terms of the volume, but it might be more than that in places where there like say tropical rainforests, where at least in the very upper layers, where there are lots of decaying plant and animal matter and all that kind of thing. This includes humus, is kind of a main type of organic matter. We've mentioned that before. And this is really good, or organic matter is good for keeping soil loose and keeping it less dense and really promoting the growth of roots. You've got air, which is kind of surprisingly, air takes up about half the total volume of soil. And now this happens because the particles in soil are not completely crammed and cemented together most of the time. In general, there's a large amount of the soil that's taken up with these empty spaces, pore spaces. And the pore spaces can either be filled with air or with water, and it just depends on what's been going on in the weather lately and the soil type, whether it kind of tends to keep the water kind of adhering to the particles or not. And finally, the fourth component of soil is water, not surprisingly, since water and air kind of trade off in terms of how much of pore space they take. Now, the two really important types of water for us, and don't worry about this type, are gravitational water, which is what happens when there's a really serious rain most of the time. The water just drains downward, and it drains past the little soil particles, and doesn't stay in the soil long enough to really be picked up by, say, plant roots or anything like that. Much more important for plants is the capillary water. And this water is not necessarily stuck on a particle level to the soil particles the way that this tightly clean water is, but it's held in kind of suspension almost, in a way that it can flow from wetter to drier areas of the soil, or it can be easily taken up by plant roots. So really, really important stuff, this capillary water. Next, soil properties, and these are especially important for us because when we're messing around with soil in class in a little bit, we're going to be looking at these. The first and most obvious is color. Now, kind of strangely, most of the time you see soil of a particular color, it's not because it came from a bedrock or a parent material that it was also that color. A lot of the time, most of the time, it's because that soil has somehow been stained or rusted or has a lot of organic or humus mixed in. So black and darkly brown soils indicate, as mentioned, humus and fertility. When you're talking about red or yellow soils, usually this happens when the iron molecules, which are hard for water to leach away, are the only thing that remain when other nutrients have been pulled away, like, basically kidnapped by the water and drained away. So all that's left are these iron molecules, and you've seen rust, it looks kind of reddish. So that's That's why a lot of soil is red. At the same time, if you go to, say, an area where there's a desert, a lot of the time the red soil isn't because there's been a lot of rain and the non-iron based materials have leached out, but it's because that is in fact just the color of the parent material. So red means different things in different areas. And when you see red around Colombia, for instance, it's probably because of this first type of red, that there's been a lot of leaching away of the nutrients in the soil. When you see gray or bluish soil, you're probably somewhere like a swamp, somewhere where there's a lot of clay. And if you remember, clay is the smallest type of soil particle. And so when you have really, really small particles, they stop water from draining through. They adhere to the water, these clay particles. And so you get poor drainage and gray bluish soil. When you have really light soil, like almost whitish soil, you have extremely heavy leaching. So even the iron oxides, those combinations of iron and oxygen in the soil, have been leached out, which is tough to do. And so that'll happen in very humid areas with lots of rain and lots of leaching. But if you're in a dry area, that white soil probably means that salt has been accumulating up. So again, different colors mean different things in different areas. A second major characteristic of soil is its texture. And so this you can tell, this basically tells us the size of the different particles in the soil. Now what you see here is an obviously completely not to scale piece of sand. But it does show you how big sand is compared to the other two main types of soil particles. So if sand is anything from about 2 millimeters to 0.05 millimeters up here, and again you can feel individual grains of sand when you're rubbing them kind of between your fingers. A good deal smaller than that is silt, which are middle-sized particles. And if silt is this big compared to sand particles, which are this big, you get an idea that there's a serious difference here. Silt, when you rub it between your fingers, can almost feel smooth, and so you won't mistake it for sand. And it can go down from 0.05 millimeters to 0.002 millimeters. Finally, much smaller than that, so small even on this blown up scale you can't really see it, is clay. Now clay is soil particles smaller than 0.002 millimeters, which means it's also so small that it can actually interact chemically with the soil. And it's important to keep in mind that no soils, well, basically no soils, are made up of only one type of particle. So when we talk about soils and their nature, we use this kind of soil triangle to describe what the soil is like. And it's kind of complicated, but not really that bad. So let's say we're going to start out with the percentage of clay right over here in the soil. If we're talking about soil that's 20% clay, we start down here and go up until we get to here, 20% clay. Follow it along here. And then let's say we've got, we're next trying to figure out the silt quotient. So we start up here and let's go up to 40% silt, which gets us right here. So we follow this line down where it intersects right here. So it looks like we're in loam. And if we were to follow that down, that would tell us that, well, obviously, because we can add up to 100, we have also 40% sand. So when you have something that's 40% silt, 40% sand, and 20% clay, then you've got loam. And loam is like the best type of soil there is for growing things. When you like reach your hand into some good fertile black dirt, that's probably loam. But then, there are different types of soil that are maybe more silty than loam, which are over here, more clayey than loam up here, and obviously more sandy than loam. So it's not too hard to figure out this triangle, but it looks a little confusing at first. And in terms of the structure, the texture is how big the particles are. The structure is how those particles clump together. And when they clump together in what are called PEDs. Now, so here's this nice little picture at the bottom shows you. You got the individual soil particles, which clump together into a big PED, and the PEDs together form basically the soil, and they show you what the structure is. Now there are three major types that we're going to talk about. We could be talking about flat plate-like PEDs, and we have a picture of that on the next slide. When these flat PEDs kind of stacked on each other like this, they make it hard because of the kind of angle that they stack at. They make it hard for water and roots and air and other things from the surface to penetrate into the soil, because they have to go kind of against the nature of the soil. And here, for example, are flat plate-like PEDs, this E example. Aside from that, you could have oblong pillar-like PEDs, which are these type right here, and these happen where the soil goes back and forth between very wet and very dry, and a lot of the time these pillars are going to be kind of like right next to each other. Sometimes you see them almost like in hexes, and they form that way because the soil cracks when it dries out after being wet. Let's see, and the long thin cracks help water and other things move vertically down through the soil. But that's not your most fertile soil. The best soil for growing things is kind of like a conglomeration of these things. These tend to be irregular, and they're kind of crumb-like PEDs. And these have a lot of air pockets in them, and they help either more air or water or roots penetrate into the soil, and so it's fertile and easy to work. And that's a little bit of a simplification, but that gets us what we want to know. Have a good night.